So, good day everyone. We are the group 7 and our topic for today is all about the compass variation and deviation. So, first, course outcome. So, our course outcome is about to solve problems related to compass variations and deviations and understand its implications on navigation. Learning outcome. So at the end of the session, the student shall be able to determine functions relating to the operations of variation and deviation. So next, importance of that topic. So variation is a magnetic interference common to all vessels. So deviation is a magnetic interference unique to the vessel itself. So we use the term deviation used to describe the effect of interference from magnetic fields created by vessels' own equipment. So it's important to know to acquire these values to have an accurate reading of the ship's heading and have an efficient voyage. So next, variation. So all information on the chart including your own plotting is related to true north. So thus, all bearings on the chart are related to true north. Compasses point to magnetic north, which varies from true north by an error called variation. So compasses also are subject to their own errors, so this called deviation. So to get deviation, we have this formula below. Compass bearing is equals to true bearing plus or minus magnetic variation plus or minus compass deviation depending on its direction. So magnetic variation, so it is due to differing positions of the geographic North Pole and magnetic North Pole. So the boat's compass and a hand bearing compass point to the magnetic pole, but all bearings on charts are related to the geographic pole or the true north. So we have this illustration as we can see. So in this case, we have the true north, the magnetic north, and the variation to the direction of the west. So the bearing M is greater than true bearing T, which is the west variation.
Around UK coast, variation is around 4 degrees west to 7 degrees west. In other parts of the world, it can reach more than 50 degrees east or west. Because the magnetic North Pole moves, the variation changes from year to year. The compass rose on the chart gives the annual change, around 7 minutes east per year around the UK. For an 1870 version of variation at 18 degrees, see chart of 1870. Next, we therefore have to convert our true bearings into magnetic and vice versa. The simple way to remember is that whenever the variation is west, the magnetic bearing will be greater than true. See the diagram above or the previous slide. You have to add variation to true bearing to get magnetic, or subtract variation from magnetic to get the true. Next, remember this mnemonic. Variation west, magnetic best. Remember that with variation west, the magnetic will be going to be best or greater than true. With variation east, magnetic least. Remember that with variation east, the magnetic will be less or less than true. If you use a plotter correctly, it will do the sums for you. So next, deviation. Boats themselves can also affect compasses due to their construction, like steel, engines, keel, ferromagnetism, electromagnetism, loudspeakers, mobile phones, handheld VHF, and deck cargo on large ships. This effect is called the deviation and will vary with the heading of the boat. You can plot a graph of the effect of change in a boat heading on the deviation. This is called the deviation curve. Deviation can be measured by swinging the compass. This is checking the compass reading when the boat is on a known heading. Round a 360-degree series of headings and plot the resultant errors. You can then read off deviation and apply this to the boat's compass heading to get the magnetic course, or vice versa. Apply it to a magnetic heading to obtain a compass course. So next, compass adjustment. So this is an example of a compass deviation curve, or the compass card. The vertical axis represents the error in degrees, and the horizontal axis represents the heading of the boat. On commercial vessels, it is so important that checks are carried out in every watch. On the standard, compass error is determined at least once per watch, and then, possible, after any major alteration of course, the standard gyro compasses are frequently compared and the repeaters are synchronized with a master compass. So next, this is the steps in how to swing the compass. First, locate two transit objects or the object in line and determine their true bearing on the chart. Second, secure the boat at anchor so that these transits are exactly aligned. Swing the boat's head until it is pointing due north. Third, read off the transit bearing on the compass and apply the variation. Fourth, the difference between this result and the true transit bearing is the deviation on this heading. If the true bearing is greater, the deviation is named east. If it is the lesser, the deviation is named west. So, the continuation of this will be reported by the next reporter.
So good day everyone, I am Deck Cadet upon the Joshua and I'm here to continue the report on swinging the compass. So on number 5, we should repeat the procedure taking transit bearings on each of the cardinal points. 6th step, from the results, make up a deviation card. Further errors are caused by boat hail and the difficulty of reading when on a moving platform. An electronic compass can be set up to remove the effect of deviation, but it is still a magnetic compass. Hand-reading compasses usually show very small deviation effects which can be ignored if you use them away from a magnetic area. Deviation can also be east or west, but the same logic applies. Deviation west, compass best. Deviation east, compass least. So here's our table for the summary and examples. So if we're looking for the variation from true north to magnetic north, we should add the west variation and subtract east variation. And if we're looking for the deviation between magnetic and compass, we should add west deviation and subtract east deviation. Next, if we're looking for the deviation between compass to magnetic, we should subtract west deviation and add east deviation. And if we're looking for the variation between magnetic to true, we should subtract west variation and east variation. So here are the examples. So for our first example, we are tasked to find the variation between true bearing to the magnetic bearing. So since it's from true to magnetic bearing, the rule applies that west variation should be added. So that's why we have the final answer of magnetic bearing of 278 degrees. So second example, true bearing to magnetic bearing. So the same rule, we should add it if it's west and subtract it if it's east. So since the variation is east, we should subtract it from the true bearing. So now we have our third and last example. So for our third example, we have the magnetic bearing of 273 degrees and the variation of 7 degrees west. So we should apply another rule for this one. So if we're finding the variation between magnetic bearing and true bearing, we should subtract west variation and add east deviation. So since we have west deviation, we should subtract it from the magnetic bearing. And that's why our true bearing is 266 degrees true. For our last example, we have the compass bearing of 177 degrees and a deviation of 5 degrees west. So the rule for this one is that in finding deviation between compass bearing and magnetic bearing, we should subtract west deviation and add east deviation. So since we have west deviation, we should subtract this from the compass bearing, and that's how we get the magnetic bearing of 172 degrees. So the next slide is an additional exercises below which you can work on so that we can enhance our fastness in computing the deviation and variation. So that would be all for our topic, and we hope that you have learned something from our lesson. Thank you.